Our next speaker is Laura Bonfini from the JRC, the Joint Research Centre. The JRC is the European Commission Science and Knowledge Service and supports the European Commission and the EU member states with scientific advice and expertise. The JRC hosts the European Onion Reference Laboratory for Genetically Modified Food and Feed and runs the European network of GMO laboratories. And I think we heard a lot about this network already in terms of networking and in terms of all the reference to the documents. Laura herself is Master of Arts in Biology and holds a PhD in Biology of the University of California. She gained several years of postdoc experience in oncology at the universities in Udine and Milan in Italy. In 2001, she joined the JRC and is since then project officer working on GMOs in the frame of the JRC work programs. The JRC GMO databases and web applications she will present now are based on her experience and expertise. Laura, we are really looking forward to your presentation. Please, the floor is yours.
Thank you very much for this nice introduction, and thanks for the organizer and Herman for inviting me to this conference and to give me us the opportunity to present the work of JRC on GMO analysis and especially on the web applications that are being developed to support the analytical work on, of laboratories for official control. So I will skip on these slides, as Guy already presented the mandate of JRC under the European Commission. And I will just mention that the JRC has been designated as European Union Reference Laboratory for Genetically Modified Food and Feed under Regulation 1829/2003 and Regulation 2017/625. Guy already presented all the tasks under these two regulations, but just mentioned two tasks that are relevant for my talk. Under Regulation 1829/2003, the JRC verified the methods submitted by the applicants for the authorization of GMOs and determined if the methods are fit for the purpose in a validation studies. Under the Official Control Regulation 2017/625, the EURAL-GMF as the task of improving and harmonizing methods of detection for official control. So, and specifically to provide details and guidance for GMO analysis, including reference methods. And it also has the coordinate the application of those methods by the official control laboratories and for that purpose organize proficiency test scheme and follow-up, as well as training for the personnel of national reference laboratories. Information on the activities of the EURAL-GMF are all provided on the EURAL website, where you can find information, guidance on detection methods for unauthorized GMO under emergency cases, on proficiency tests, method validation, the activity of the European network of GMO laboratories that's been mentioned many times, and particularly that the focus of my talk is on some web application that are being designed to help in selecting the appropriate method of detection or design screening approaches and interpreting the results, or for query public database for putative GMO applicants. This web application are GMO methods, the GMO matrix, and the GMO applicants. So the GMO method database is a collection of state-of-the-art DNA-based assay for GMO analysis. It was developed by the EURAL-GMF to fulfill his task in the provision of a EU reference method for official controls. And it includes methods that have been validated in collaborative studies according to the requirements and principle of international standards as ISO or international unions of applied chemistry, UPAC protocols. And in addition, the methods also have to be in line with the requirements established by the NGL in the guidance for minimal performance requirement for analytical methods for GMO testing. And include also some methods that have been verified in a single laboratory study for EU legal purposes. So since the methods are selected according to these requirements, they can ensure accurate and reproducible results. Oh, sorry. In the database, you have a downloadable PDF summary where you can find information, or general information about the methods and the target, the design of the collaborative study, the performance of the method in the study, a link to the reference to the publication, and the information on primer and probe sequences for the GM and the taxon target, and experimental condition for the PCR reaction setup and the amplification condition. Actually, currently, the GMO database contains 95 event-specific methods which cover all authorized GMO, plus some unauthorized one, but also element and construct-specific method for organizing, designing, screening strategies. And additionally, taxon-specific method to determine the percentage of the GMO at the ingredient level. So this the GMO method application allows you to select the methods, but we have other applications to perform in silico PCR prediction for GMO detection using those methods. Those are the GMO matrix, GMO event finder, GMO screen, which allow to design screening strategies, interpreting the results. In addition, you have also some proposal for screening, both in a general approach or for detecting all authorized GMO in Europe. So the GMO matrix perform in silico PCR prediction and assemble two-dimensional matrices where you have chosen GMO events on the horizontal line versus chosen GMO methods on the vertical line. And to visualize the analytical coverage of the methods and possibly identify potential gap in the analysis. So the user in the web interface can select the taxon or taxons or the GMO he wants to cover, the legal status, and select the methods he wants to use in the screening. As a result, by clicking show, the user has a table where you had the events, a list of events, and their coverage by the selected methods. There's a color code, since the application perform an in silico analysis using the primers of the methods against the sequences of the GMOs, which are included in an internal GMO database. These sequences are provided by the applicants for the authorization of the GMO or independently retrieved by JRC colleagues from public databases. So there's a color code, and for which the green color indicates that based on the silico analysis, there's a prediction of positive amplification with the primers of the method. The red color indicates no amplification. The orange color indicates a not perfect alignment of the primer and a possible amplification. It's the GMO matrix allowed to connect by linking on the event name to the BCH database and retrieve more information, as well as clicking on the method's name to retrieve more information on the experimental condition, but also in addition, there's information on the authorization status of the events that are covered by the screening, and they are indicated here in this circle. This information is retrieved from the GMO register of DG Santé, is daily updated because the two databases are connected, so the user can have an updated information also on the coverage at the authorization status. So this, so the GMO matrix at the moment includes, in this table, on the left, you can see the events for species are included in the GMO matrix, and on the right side, the table indicates the coverage of the GMO by each type of method. So you can see that here there are about 10, 11 element-specific methods which you can detect in silico at least more than 20 GMOs. So we have GMO matrix allowed to design screening strategy, and the application GMO Event Finder can allow you to interpret the results of those screening strategy. Indeed, the user can select the taxon and then insert the methods that provided positive amplification, and in the third section, the methods that provided negative amplification, and also can select the maximum number of events. By clicking Show, the application provides a table listing the event that could explain by themselves the pattern observed experimentally. And additionally, it provides also a table listing the event that could be present in the sample, but that could not explain the pattern by themselves. Because, of course, with the increasing number of GMOs, there's also complexity, more complexity in the interpretation. Given that the GMO that are authorized in Europe are been increasing the last years, and then the analysis and the design of the screening approaches has become more complex. We have developed this web application to help laboratory in their work. So we provide also some proposal for screening authorized GMOs by species, or for one taxon or more than one taxon, and a general screening approach to cover also not only the authorized GMO, but more unauthorized as well. Of course, this type of script proposal will not be comprehensive, given that in the presentation from BCH, there are so many GMOs on the market right now. And then we have a third possibility to select pre-spotted plates, which is a multi-target device developed by the JRC, providing the possibility to screen for many GMOs in one single experiment. So, for example, if you want to perform a screening for detecting all authorized GMO in a taxon, you select the taxon you want to screen for, the legal status, you press Show, and you have in this table the view of the coverage of the methods for the authorized cotton event and also pending one. You also see the pattern of coverage for the unauthorized one, if they're included in the GMO matrix. Then you have also an interface to interpret the results of that screening. So if you select and interpret the results, you have the methods use in the proposal, and you can select if you had a positive amplification or negative amplification with those methods and see which possible events could explain the pattern observed experimentally with those methods. And again, as before, you have the possibility to see which other events could be possibly present in the sample and in addition to the previous list. If you want to have a more discriminatory power or have a more general approach for the screening, there's also a possibility to select this option and have a table listing more methods for the screening. There are about 10, 11 one, and their coverage for the event that the user has selected. And again, you have an interpretation table suggested, where you can, by inputting the results of the taxon, element, construct, the event-specific method, you can have interpretation table. Of course, you're not obliged to use all these methods, and you can just select the results here of the methods that the user have used in their screening and just leave a question mark for the methods that have not been used. This is to give flexibility to the user to design his own approach for the general screening. And again, you have the same possibility to interpret the results of the screening. The last option in the GEOMO screen application allows to input the result of the pre-spot template that, as I said, the JRC has developed and make available to the laboratories for performing the official control analysis in a more time-efficient manner. Again, here, the results of the screenings are inputted in the interface, and then the application will provide a possible interpretation of the pattern observed experimentally. So we have seen that we have a web application, GEOMO methods providing the methods, GEOMO matrix for design, the experimental approach, GEOMO event finding for interpreting the result, or GEOMO screen to have a pre-made kind of screening proposal. The last web application, GEOMO Amplicons, allows to query a public sequence database for putative GEM amplicons using the AU reference method. The application performs in silico analysis using the primers of the AU reference method on different public databases, which are the user can select from the interface. So it can perform the query on the NT and CBI database on 3 types of pattern database managed by the MBL. It can also select the maximum number of gap mismatches and then view a table indicating all the records that have been in silico recognized as possible target for the event selected. The table provides the general information on the records retrieved from the public database, the length, the amplicon sites, and in addition, by clicking View, you can have more information on the amplicon sequence, the mismatch and gaps, and the aligning of the primers on that target. The user can also do the opposite or reverse approach, so select a target in the public database and see which methods can actually recognize in silico that target. So for example, if you input a record of a public database here, the application will perform a silico analysis and indicate that this event-specific method can recognize that target. Here in this table, you can see the percentage of methods from the total methods included in the JRC database, which can recognize a target in public database. For example, you see that 100% of the element-specific methods recognize at least one target from NT and two of the public patent databases. And even 70% of the event-specific methods can recognize a target in a patent database. So it can be a very convenient application to verify the specificity of a method, to develop a taxon-specific method, or to find elements for the development of methods for detection of unauthorized GMO. In conclusion, the GMO method database and this other ARL GeoMF web application can ensure analysis on accurate sequences because they are provided directly by the applicants, ensure consistent and reproducible results because the methods are being validated in collaborative study and ensure performance according to NGL requirements. The information always updated and comprehensive. We have comprehensive bioinformatics suite to perform all different types of analysis for GMO official control. And this will facilitate confidence in the results, harmonization of GMO analysis, trade and consumer trust, and hopefully help the work of the laboratory for official control. On the web pages, we also have give the chance to the user to provide feedback and to improve the service we provide and for suggestion. We already received a suggestion to provide the database in Spanish, but I don't think that we will work on that, on providing the databases in different languages, but I thought it was quite funny. And I would also like to acknowledge all the colleagues that work for the development of this web application. Benny Kasser from DG Santé, that work in collaboration with our IT consultant, Moreno Colayo-Covo, for the exchange of information so that the information on the authorization status is daily updated in the GMO matrix. Also, I would like to acknowledge our colleague Mauro Petrillo, Alexander Angers, which first developed the GMO matrix, the GMO amplicons, and the GMO Event Finder application, and IT consultant Moreno Colayo-Covo, which further developed those applications and that developed the GMO screen web application. Finally, I would like to also thank Enrico Ben for the IT support. Thank you, everybody, for listening online and here, and I hope that this web application will make life and the work in the laboratory more efficient. Thank you very much.